Hello, National 5 Chemists. It's Mr. Morton here. I hope you're all doing really well. Today's video, again, we're continuing on Unit 3. We're continuing with this idea of fertilizers. And in the last video, we started to talk about this kind of quite useful and special compound called ammonia and how useful it was for making fertilizers. Today we're going to talk about how to make ammonia. Since ammonia is so useful, we need to know how to make it. And we're going to talk about a chemical process invented in the early 20th century, around about 1918, I think, by a very talented chemist called Fritz Haber, who won the Nobel Prize for this process as well. So, um, a little bit complicated, but we'll try and strip it down and really focus in on the specifics that we need to know for our National 5 chemistry course. Okay, so the Haber process then, we're thinking right now about making ammonia, making this NH3 molecule. If we just took a minute to look at ammonia, it's made up of nitrogen and hydrogen, so it would make sense that we used nitrogen and hydrogen to produce it. And that's exactly what we're doing. That's exactly what the Haber process does. It's a very simple chemical reaction. We're taking some nitrogen from the air, some hydrogen which has been electrolyzed from some water, reacting them together to produce ammonia gas. Now, you need to be able to remember that to produce ammonia, I need to react together nitrogen and hydrogen. And we also need to be able to write out this balanced chemical equation. We've got the diatomic molecule nitrogen reacting with the diatomic molecule hydrogen. N2 plus H2 is giving us ammonia NH3. And then once we've balanced it out, we'll have 3 moles of hydrogen and 2 moles of ammonia. Now, you might be looking at that chemical equation and thinking to yourself, well, that arrow looks a little bit different from the arrow that we normally draw in, and that is correct because that arrow is a special arrow which indicates that this chemical reaction is reversible. Now, all I mean by that is that this ammonia quite happily will break back down by itself to produce nitrogen and hydrogen again. It's not the most stable chemical in the world, so if given the chance, it will rather be the nitrogen and hydrogen. But we can force these two chemicals together to produce ammonia, so it's almost like a kind of continuing circle, if you will, of producing ammonia and breaking it down, producing it, breaking it down, etc. So this is a reversible reaction, and that's what that arrow indicates. So again, that's another key thing that we need to appreciate about the Haber process. Some extra information here goes into maybe a little bit too much detail, but just to kind of give you a little flavour of what's going on. As I said, we're taking some nitrogen, some hydrogen, reacting them together to produce ammonia. The ammonia breaks back down, so we're never going to have 100% conversion of all of our nitrogen and hydrogen producing ammonia, and that's it, because the ammonia is always going to want to break back down. So that's a challenge to overcome. And as stated before, this process of producing ammonia was invented by the very talented chemist Mr. Fritz Haber, and he got the Nobel Prize for it in 1918. And again, we don't need to go into this much detail for a National 5 course, but essentially what he realised is by changing and altering the temperature and pressure of this chemical reaction, he could vastly increase the yield of ammonia and stop it, or at least slow it down from breaking back into the nitrogen and hydrogen. That was the real kind of breakthrough, is to try and keep this ammonia as stable as possible and to produce as much of it as possible. Now, here is an overview of the Haber process that we will run through, and I'll talk about the important things that we need to remember, because we don't need to remember all of it by any means. You'd be never expected to draw out this diagram of the Haber process and explain it from start to finish, but you would be expected to know some key points. So let's go through the key points. First key point, obviously, is the starting products. We take some hydrogen, we take some nitrogen, and we're trying to force them to react together. As we've said, Mr. Fritz Haber realized that this ammonia doesn't really want to be ammonia, it wants to break back down into hydrogen and nitrogen. So we need to try and encourage as much ammonia to be produced as possible. And the first step to that was to increase the pressure, to force the hydrogen and nitrogen to come together to start to react. So that's what the first step is, this compressor here. Then the compressed gas is passed into a reasonably hot chamber, around about 450 degrees Celsius, to again help encourage these gases to react together. And those gases are then passed, and this is an important point, passed over layers of a catalyst. So there's lots of different layers to increase the surface area. So there's lots of catalysts in here. And the catalyst for the Haber process is the metal, the transition metal iron. So right now there's really three things that we need to appreciate. Hydrogen and nitrogen going in. There's two of them. Hydrogen one, nitrogen going in. Second thing for us to really appreciate is the use of this iron catalyst to help speed up the reaction. Not too worried about the temperature and the pressure, but it's nice to know about. And then once these gases, hydrogen, nitrogen, have passed through the catalyst, passed in the warm environment at the high pressure, they've reacted to form ammonia gas, and they're cooled and extracted to be used to produce fertilizers or any other chemical from it. But what's interesting to note as well is even after all of this big process, increasing the pressure, increasing the temperature, using a catalyst, forcing these chemicals to react, there's still quite a bit of hydrogen and nitrogen that's coming out unreacted. So what the Haber process does is it feeds back anything unreacted to go again and to try and react it into ammonia. So anything that comes out of this reaction vessel that isn't ammonia gets separated and put back in again. And that is a great way to increase the yield of our chemical reaction. And here's a nice little way to remember the key points of the Haber process that I've talked about. Now, if you know me, you'll think this is funny, no doubt. But the word to remember for the Haber process is hair. Now, why is hair so important? Well, I don't think it's that important, but it is for the Haber process, and it is for learning the Haber process. So here, H for Haber. What is produced in the Haber process? A. Ammonia. What is the catalyst used in the Haber process? I for iron. And what kind of reaction is this? It is a reversible reaction. So that will help you remember some of the key points to the Haber process. Producing ammonia uses an iron catalyst. It's a reversible reaction. Some other key things to think about and to remember as well are, can you write the balanced equation for the Haber process? Do you know the chemical formula for ammonia, NH3? So again, it doesn't highlight everything here that we need to know, but it goes a long way into helping us remember. Okay guys, and that's the Haber process done. I hope you found that interesting. I hope you found that useful, and I'll see you again next time.